Hello, class. Today we'll be talking about 11.6 events involving not and or odds. So, in this section, we're going to be using some of the previous knowledge that we just learned from 11.1 through 11.5. So, we're going to find the probability that an event will not occur. We're going to find the probability that an event or a second event occurs. And we're going to understand how to use odds. So let's look at this. The probability, all right, it says the probability of an event not occurring, the complement of E. If we know the probability of E, the probability of an event E, we can determine the probability that the event will not occur, denoted as the probability of not E. It says the probability of that the event occur, the event will not occur is equal to 1 minus the probability that it will occur. So we got the probability of not E is equal to 1 minus the probability of E. So first you have to figure out what is the probability of E, right? Then you got to subtract that from 1. Now, remember the probability E will either be in what? Fractional form or decimal form. So the probability of an event will occur is equal to 1 minus the probability of the event not occurring. So the probability of E is equal to 1 minus the probability of not E. So take a minute and write that down. So let's look at this problem. It says if you're dealt one card from a standard 52 card deck, find the probability that you are not dealt a queen. So the first thing is figuring out what is the probability of being dealt a queen. All right. So the probability of E, we know we have what? We have 4 queens in the deck, and it's out of 52. So we know that is what? Basically 1 over what? 13. Now, trying to figure out the probability of not E, we have to do what? So the probability that this won't happen is equal to 1 minus my 1 over 13. And when you put that in the calculator, you should get what? 12 over 13. So keep that in mind when you're doing these problems. Make sure you understand what you're actually doing. So you have to figure out what the probability of that event happening. Then you have to do what? Subtract it from 1. So make sure if you have any questions about what I did, you send me a message through Microsoft Teams or you send me a message through email. All right. So let's look at this. Mutually exclusive. All right. Mutually exclusive events. Event A and B are mutually exclusive if it is impossible for them to occur simultaneously. Or the probabilities with mutually exclusive event, if A and B are mutually exclusive events, then the probability of A or B is equal to the probability of A plus the probability of B. Now, in set notation, we have the probability of A union B is equal to the probability of A plus the probability of B. Now, they're the same thing. It just one is in just written out form as ors, or you can use the union, which is this symbol here. All righty. Let's look at something. So it says, One card is randomly selected from a deck of cards. It says, what is the probability of selecting a king or a queen? Now, selecting a king or a king is not a queen and a queen is not a king. So they are mutually exclusive. So one does not affect the other. So if we know we have what? So we could say that we have the probability of getting a K or a Q, that's king or queen, is equal to the probability of getting a king, which is what? 4 over 52, plus the probability of getting a queen is 4 over 52. So basically that's what? 8 over 52. Or we could write what? 2 over 13. Now, remember, we just figured out what's the probability of getting a queen in our last thing. So now we know it's 4 out of 52 because it's 4 kings in the deck, because it's 4 suits. It's 4 queens in the deck because it's 4 suits. So you add the two probabilities together, then you simplify. So you should have got 2 13s. So let's look at this. It says probabilities with events that are not mutually exclusive. Now, if A and B are not mutually exclusive events, so basically they affect each other. If one happens, it affects the other. All right? Now, it says then the probability of A or B will occur is determined by adding the individual probabilities, then subtracting the probability of A and B will occur simultaneously. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now we put that in set notation. It says the probability of A union B is equal to what? The probability of A plus the probability of B minus the probability of A intersect B. So basically this is what they have in common. All right? So that's what they have in common. So let's actually look at a problem with this. So in a group of 25 baboons, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy doing both. It says if one baboon is selected at random, find the probability that it enjoys grooming his neighbor or screeching wildly. So, I'm going to say, if we look at everything, so we got the probability of grooming or screeching is equal to, now, if we look at it, we're looking at the probability of grooming, which would be what? It tells us it's 18, and that'd be 18 out of 25. Plus, the probability of screeching would be what? 16 out of 25. Let me straighten that up. Minus the probability of them doing both, which would be 10 out of 25. Now, when we add all these up together and subtract, we get what? 24 out of 25. So basically we have what? 24 out of 25, or 24 of the baboons enjoy doing what? Grooming their neighbors or screeching wildly. Now we have that one person that one baboon that don't like doing either. So this is what they're asking for. Make sure if you have any questions about this, you send me a message as soon as possible. Now, we're going to look at odds in favor of E, and we're going to look at odds against E. Now, the odds in favor of E is equal to the probability of E over the probability of not E. So basically, you already know how to find the probability of E, and you already know how to find the probability of not E. So now you just divide them to figure out the odds in favor. And the odds against would be what? The probability of not E all right, over the probability of E. Now, stuff like this, you hear odds and stuff like that when they're talking about horse races or dog races or when they're trying to bet on something, all right, boxing or whatever else. So make sure you understand what we're actually doing. So let's look at this problem. So this problem says you roll a single six-sided die. It says find the odds in favor of rolling a 2. So remember, let's look at the sample space of a single six-sided die. So we can only roll a 1, a 2, a 3, a 4, a 5, or a 6. All right? So basically we have what? We're in my event, we have what? We're just having roll a 2. Therefore, the probability of this happening will be just 1 out of the 6, right? Easy. And the probability of this not happening will be equal to 1 minus the 1 6, which just equal what? 5 6. Now we're going to do what? We're going to find the odds what? In favor all right, so we're going to put the probability of E over the probability of not E. Erase that. All right, now, so that'll be what? 1 6 all over 5 6. Now, when you put that in the calculator, you just get what? 1/5. And that is the odds in favor, 1/5. So you have a 1/5 of a chance of getting what? A 2. That's the odds in favor, 1 to 5. Now, let's look at another way of looking at this. Odds to probability. If the odds in favor of event E are A to B, then the probability of the event is given by the probability of E is equal to A over A plus B. This is a real easy thing to remember. So let's look at problem. It says the odds in favor of a particular horse winning a race is from 2 to 5. Find the probability that the horse will win the race. So the probability of the event is equal to A, which is what? 2. Then we have A plus B, which would be 2 plus 5. So the probability is 2 7ths. And that's all you got to do. So the probability that the horse will win the race is 2 7ths. Now, if you have any issues with 11.6, make sure you send me an email. If you have any issues, send me an email or send me a message through Microsoft Teams. The quickest route is Microsoft Teams because it sends it directly to my phone.